Assalamualaikum and a very good day to Encik Rashid. We are from Group 8. Today we'll be presenting about design project. Before I begin, allow me to introduce myself. My name is Eli Aliza binti Jeffrydin. My metric number is 01DKA20F2011. Now, as you can see on the screen, there is the table of content. From what we can see, there will be 9 content. First, introduction. Second, company profile. Third, drawing plan. Fourth, spec of element. Fifth, name of element. Sixth, originality. 7, beam design. 8, slab. 9, column. Next is introduction. The name of this project is Taman Bayu. This project is located in Meru Klang, Selangor, while the type of housing here is double-story terrace house. Each of the house unit comes with 4 bedroom and also 3 bathroom. The land area for this project is 24 times 92, or easily understood as 2,238 square feet. And the pricing for this unit starts with RM550,000 ringgit.
Okay, so here is our company profile. Which is BAA Engineering Industry Sendirian Berhad. It is the local construction and structural industry main player. It was founded in 2008 to help BAA Group with strategic management planning to improve productivity and efficiency, state-of-the-art computerized equipment and Tekla structure 3D software have been introduced from her inceptions. BAA Engineering has established itself as a leading structural company that provides decent service while adhering to internationally recognized safety practice backed by a string of successfully completed projects. In order to maximize productivity, BAA Engineering has recently implemented an industrial building system which is known as IBS and precast concrete works. It has higher quality control because all elements are finalized in the factory, reducing dependency on people and building deadlines. BAA Engineering has attained the needed results via continual improvement, professionalism and a commitment to staying focused on customer needs. And BAA Engineering is centrally positioned in Damansara Heights, Kuala Lumpur, and the fabrication yard is 18,000 square meters in size and has a lifting height of 12 meters.
So this is a drawing plan. So the left is a plan of ground floor and right is first floor plan.
So this is a spec of plan. So first is structure. Use the reinforced concrete frame. So for the wall, brick, sand, cement. Roof frame, using the iron roof frame. For the ceiling, using the ceiling plaster. And the window, for the window, front and the back of house, using aluminium frame window. And door, so for the door, we use the plywood door. Floor finishing, for kitchen and bedroom, we using the ceramic tile. And yard, parking lot and path, using the ceramic floor. And wall finishing at bedroom with using the ceramic tile. And another plate, using the quality pin. So last is fin. For the side and back, we use the chain link fence. Next slide is name of element. In the context of designing double-story reinforced concrete building, the specific elements that play crucial roles include columns, beams, slabs, foundation and also walls. As for column, it is a vertical load-bearing element that transfers the weight of the structure above the foundation. And for beam, it is horizontal load-bearing elements that support the floors and transfer load to the column. And for slab, it is horizontal plate that form the floors and roof of each story. Foundation, it is the space structure that distribute the weight of the building to the ground. And last but not least is wall. Structural walls that provide lateral stability and support vertical loads. So, this element works together to create a robust and stable structure for a double-story reinforced concrete building.
As for the originality, we have our own originality, which is Zeitgeist and creativity. Zeitgeist is a German term that translates as spirit of the age. For instance, an art movement that embodies a period and location that will never be replicated. This concept implies that original styles from the past can be imitated, but not authentically. The thrill of discovering something new happens only once. And as for the creativity is a productivity that produces unique value. This phrase is overused in some disciplines, such as graphic designs, and underused in others, such as business strategy or algorithm.
Hi, my name is Nabihah Uzma binti Hazri. My metric number is 01 aka2 F2032. So now I want to explain about calculation for the first floor of the beam. So now I want to explain for the first step. Effective span length is 4.3 meter. Characteristic action for the permanent GK 60 kilonewton, variable QK 9 kilonewton. As bar 1 is 20 mm, bar 2 60 mm, link as 6 mm. So characteristic for the stress of concrete FCK 22 Newton mm. Characteristic for steel FYK 500 Newton, and characteristic for link FYK is 1500 Newton. So for the size of the overall deep is 4,300 over 30. So the answer is 331 mm. So y is 0.4 times 331, and the answer is 132.4 mm. So next is loading load and analysis. For the beam safe weight 0.21 times 33 times 25, and the answer is 173. So design action calculation is 1.35 times 70.73 plus 1.5 times 9.00, and the answer is 37.43 kilonewton. So for the surface VED, the answer is 39.58, and for bending moment MED, the answer is 86.51 kilonewton. This is the calculation for. So now I want to explain about main reinforcement. So the effective deep for the D is 331 minus 35 minus 6 minus 60 minus 0.5 times 20. The answer is 264. And next D is 35 plus 6 plus 6 over 2. The answer is 49. So for the calculation of the K, the answer is 0.496, and then K is more bigger than K bar. So the answer of K bar is 0.167. So next is conversion reinforcement. So the Z answer is 153.12 mm, and X of the calculation D minus Z over 0.4, and the answer is 277.2 mm. And last, D over X, the answer is 0.80, small than the 0.38. So calculation of area of compression steel, the answer is 566 mm, and area of tension steel, the answer is 1059 mm. Minimum and maximum reinforcement area. So the S-min calculation, and the answer is 100.42 mm, and the X-max is 1753 mm. Now, shear reinforcement. So for the calculation, shear reinforcement is for the concrete street capacity. So calculation of VED as max, for the answer of 22 degrees is 286 kilonewton, and for the 45 degrees is 160 kilonewton. So next, for the shear link, for the shear link calculation of ASW over S, so the answer is 0.155. So tri-link is H6. So the number of ASW is 57 mm, and spacing answer is 356 mm, and the max of spacing is 198. So for the minimum link, so the SW over S, the answer is 0.095, and tri-link is H6. So the spacing calculation is 57 over 0.10, the answer is 570 mm. So shear resistance of minimal link, V min, the answer is 49 kilonewton. For additional longitudinal reinforcement, for the additional tensile force, the answer is 49.08 kilonewton, and MED max over Z, the answer is 564.98 kilonewton. So next, for the AS, the answer is 112.83 mm. Deflection. So deflection percentage of liquid tension reinforcement, for the P calculation is 1059 over 132.4 times 264, and the answer is 0.030. Reference ratio. So the PO, the answer is 0.0045. So percentage of compression reinforcement, the answer is 0.017. So factor for structural system K, the the answer is 12.00. So the modification factor for span greater than 7 meter, the formula is 7 over span. The calculation 7 over 4.3, the answer is 1.63. And then modification factor for steel area provided, AS provided over AS revision 1131 over 198. The answer is 1.07, and then small than 1.5. So therefore, allowable span effective slip ratio, the answer is 20.92. So actual span effective dip is 69.29 is allowable, is okay. Next is cracking. So limited cracking with W max is 0.3 mm. Still stress is, the answer is 225 Newton per mm. So max allowable bar spacing is 200 mm. So calculation and total answer is 50.2 mm. So more the small than 20 mm.
Hello and hi everyone, my name is Athirah binti Razali and my registration number is 01DK80F2002, and now I'm going to share with you the ground floor for beam. Okay, as for the effective span is 6.7 meter and the GK is 18 kilonewton, QK is 10 kilonewton and FCK 20 newton and FYK is 500 newton. As for the design action is 43 kilonewton and the shear force is 144.05 kilonewton, and as for the bending moment is 241.28 kilonewton. Next, as for the main reinforcement, we need to find the D and D prime by using effective tab, where we got 449mm for D and 49mm for the D prime. And for the design bending moment, MED is 241 kilonewton and we can find K, which is 0.29. Next is redistribution. We need to find the cable, which is 0.167, where the K is larger than cable, so the compression reinforcement is required. Then we got Z, which is 368.18mm, and X we get 202.05mm. So the compression steel will have yielded FSC is 0.87 FYK. Next, the area of compression steel, which is AS prime, we got 587mm, and the area of tension steel is 1453mm squared. Next, we need to find the minimum and maximum reinforcement area, which is we need to find AS min, where we got 120.24mm squared. And as for the AS max, it is 0.04 AC, which is equal to 4251.84mm squared. Next, for the shear reinforcement, we need to find VRD max for both 22 degrees and 45 degrees. As for the 22 degrees, we got 211 kilonewton, and as for the VRD max for 45 degree, we got 602 kilonewton. We use the angle 22 degree, so theta is equal to 0.5 sin VED over 0.18 BWD FCK 1 minus FCK over 250, where we got the final answer is 14.02. Next, we need to find the ASW over S, where we got 0.332, and then we try to use the link H6, which is the ASW is 57. So 57 over 0.332, which is equal to 171. So the max spacing S max 0.75D, which is equal to 0.75 multiplied by 449, which is equal to 336.75. Next, for the minimum links, ASW over S is equal to 0.147. So we use try to link H6, which is ASW equal to 57 millimeter squared. So the spacing is 57 over 0.15 is equal to 380, which is smaller than 0.75T, which is equal to 0.75 multiplied by 449, and then it is equal to 336.75. Next, for the shear resistance of minimum links, for the V min, we got 70.72 kilonewton. Next, for the additional longitude, the additional tensile force is 178.56, and then MED max is divided into Z's, where we got 654.58 kilonewton. And as for the additional longitudinal reinforcement, we got the final answer is 410.48 millimeter squared. Percentage of required tension reinforcement, AS required divided into BD, which is we got 0.016, and then reference reinforcement ratio, where we got 0.0048. Next, for the factor for structural system, which is K equal to 1.0, we use equal to, where if you look closely on the slide, it is the formula where the final answer we got 13.01. Next, for the modification factor for span greater than 7 meter, we got 1.04, and then the modification factor for steel area provided is AS provided divided into AS required, where we got 1.05, where the AS provided is 1,810, and the AS required is 1,453, where we got the final answer is 1.25. And then we try to L divided into D to find the allowable, which is 16.91, and the L over the actual is 14.94, and then therefore there will be the allowable is larger than actual, which is it is okay because allowable is larger than actual.
Next is slab. Starting with first floor slab, which is bedroom 2. So on the left side is the original plan, and on the right side is where we drew before we start calculation. So here it is the action. As for GK is 1.5, QK is 4, FCK is 25, FYK is 500, bar is 10 mm, and for CNOM is 25 mm. As for design slab panel is BD/13. LY is 3,500 and LX is 3,200. LY divided by LX equals to 1.09. It is smaller than 2, so it is a two-way slab. Design action and ED equals to 13.09. The case for this slab is case 4, which is 2 adjacent edges discontinuous. For short span, 1 is 5.63 and 2 is 7.51. For long span, 1 is 4.56 and 2 is 6.03. As for main reinforcement, dx equals to 120, dy equals to 110. Minimum and maximum reinforcement area, AS min equals to 156 and AS max equals to 6,000. So secondary bar is H650, which is 189 mm square per m.
Last but
For
not
main
least is task
reinforcement,
2,
short
which is
span
design review of cold
MSX1,
water system
AS equal to
versus sanitary pumping system.
113.53, so we use
First step.
H6225, which is 126 mm square per m.
First
For
step is
support,
by doing
MSX2,
interference check.
AS
On
equal to
collaborate tab, click interference check and then
151.44,
select this
we
category
use
that shown in the diagram.
H650, which is
Then run
189
interference check.
mm
Then the
square per
interference
m.
will
For long span,
then the
which
interference
is
report will be generated.
MSY1, AS
After
equals
that,
to
the clutch item will be highlighted as shown in the
use
diagram.
H6
As you can see
250,
from the
which is
diagram on the
113
slide,
mm
the
square per
material of
m.
the pipe
For support
fitting for this pipe are
MSY2,
not correct.
AS equal
Hence,
to
this is a strategy on how to deal
132.65.
with
We
the
use
problem.
H6 200, which is 141 mm square per m. For shear,
Hence, the
design
strategy
shear
on
force
how to
VED
deal
equals to 18.43.
The strategy on how
So
to deal with this problem
VRDC
is to
equals to
change the material of
46.65.
is to
Vmin equals to
change is to change
59.43.
the
So
material of pipe fitting,
VRDC,
which is to
which is
polystyrene.
46.65,
Finally,
smaller
run
than
interference
VD,
check again.
so it is
Then
okay.
refresh to update the
Next
report
is
on
deflection.
interference. If the
LD
correction is
equals
made
to
correctly, it will show no
172.35.
interference detects between the
For
core system.
allowable is 229.23.
It will
So
show
for
no
LD
interference
actual,
detect
which
between
is
core water system
29.17,
and
it is smaller than allowable, which is 229.23. So
it
it
will
is
show no
okay.
interference detect between core water
Next is
system
cracking.
and
For main
sanitary
bar,
plumbing system.
max
That's
bar
all from me. Last
spacing
but not
is
least is task
250,
which is design
which is
review
smaller
of
than
cold water system
max slabs, which
versus
is okay.
sanitary
And for
plumbing
secondary
system.
bar,
First step,
max bar spacing is 150, which is smaller than
first step is by
max
doing
slabs,
interference
also
check.
okay.
On
So
collaborate
for
tab,
detailing,
click
here
interference
as you
check
guys can see, this
and
is
then
the
select
detailing
this
for
category
first
that's
floor
shown in the
slab, which is
diagram.
bedroom 2.
Then run
Next
interference
is
check.
first
Then
floor
the
slab, which is
interference
master bedroom.
then the
This is the
interference report will
original
be
plan.
generated.
And on the right side
After that,
is
the clutch
the
item
plan
will
that
be
we drew
highlighted as shown
before
in
we
the
did
diagram.
calculation.
As you can see
So
from the
for
diagram
action,
on the slide,
the slab
the
thickness
material of
is
the pipe fitting for this pipe are not correct.
171.43, so we
Hence,
try
this
H
is a
equal to
strategy on how to deal
180.
with the
It is
problem.
also a two-way slab because it is smaller than 2.
Hence, the strategy on how to
For
deal
design action, NED
hence,
equals to
the strategy on how to deal
14.01.
with this problem
And
is
for
to change the
analysis,
material of
it is also case
is
4,
to
which is
change
2 adjacent edges is
is to change
continuous.
the material
For
of
short
pipe
span,
fitting, which is to
MSX1 equals to
polystyrene.
15.77,
Finally, run interference check
MSX2
again. Then
21.22,
refresh to update the
long
report on
span equals to
interference. If the
MSY1
correction is made correctly, it will show
9.75
no
and
interference detects
MSY2
between the core system.
12.91. For main reinforcement,
It
DX
will show
equals to
no interference
150
detect
and
between core
DY
water
equals to
system
140.
and
For minimum and maximum reinforcement area, AS min equals to
it will show no
195 and
interference
AS
detect
max
between
equal
core
to
water system
2200.
and sanitary plumbing system.
For
That's
secondary
all from
bar,
me.
we
Last
use
but not
H
least
at
is task
225, which is
design
223
review of
mm
cold water
square per
system
m.
versus
Main
sanitary plumbing
reinforcement
system.
for short span,
First step,
AS equals to 254.41. We use
First step is by
H at
doing interference
175,
check.
which is
On
287
collaborate tab,
mm square
click
per m.
interference
For
check
support,
and then select
MSX2,
this category that's shown in the
AS is
diagram. Then run
342.33, so we
interference
use
check.
H at
Then the interference
125, which is
then the
402
interference
mm square
report
per
will be
m.
generated.
For long span, MSY1,
After that, the
the
clutch item
AS
will be
is
highlighted as shown in the diagram. As you can see from the
168.52.
diagram
We
on the
use
slide,
H8
the material of
to
the
150, which is
fitting for
201
this pipe
mm
are
square
not
per
correct.
m.
Hence,
For
this is a strategy on how to
MSY2,
deal
AS
with the
equals
problem.
to 223.14. We use H at 200,
Hence, the strategy on
which
how
is
to deal
251 mm square
Hence,
per m.
the strategy on
For
how to
sure,
deal with this problem is to
VSX1
change
equals
the
to
material of is
23.77,
to change
VSX2
is to change
22.08,
the
long
material of
span
pipe fitting, which is
VSY1
to polystyrene.
25.98,
Finally,
VSY2
run interference check again.
16.89.
Then refresh to update the
And
report
for
on
design shear
interference.
force,
If the
VED
correction
equals
is
to
made correctly, it will show
33.77.
no interference
So
detects between the
for
core system.
VRDC equals to
It will show no
67.60.
interference
Vmin
detect
is
between core water system
74.25. So
and
VRDC, which is 67.60, is
it
bigger
will show
than
no
VED,
interference detect
which is
between core water system and
33.77, so
sanitary
it is
plumbing
okay.
system.
And for
That's all from me.
deflection,
Last but not least is task 3, which is
the
design
LD
review of
equals
cold
to
water system versus
99.164.
sanitary
For
plumbing system.
allowable span
First
effective
step-
nerve depth ratio, which is allowable, is
First step is by doing
112.6.
interference check. On
And
collaborate
for
tab,
actual
click
span
interference
effective
check
length,
and then
which is
select this
actual,
category that's shown in
is
the diagram. Then run
33.04.
interference check.
It is
Then the
smaller than
interference-
allowable, so it is
Then the
okay. And
interference
for
report will be
cracking,
generated.
the maximum bar
After that,
spacing for
the
main
clutch
bar is
item will be highlighted
250,
as shown in the
which is smaller
diagram.
than
As you can see
max
from the
slabs,
diagram
which
on
is
the
okay.
slide, the
And
material
secondary
of
bar,
the pipe
max
fitting for this pipe are not
for bar
correct.
spacing
Hence,
is 2
this
to
is a
5,
strategy
which is
on how
smaller
to
than
deal
S
with the
max
problem.
slabs, also okay. So last but not least, this is the detailing for
Hence, the
first floor
strategy on how
slab,
to
which is
deal-
master bedroom.
Hence,
Next is ground floor slab, which is bedroom 1. On the left side is the original plan, and on the right side is the plan that we drew before we start with the calculation. Action. The design panel slab is CD/35. The thickness of this slab is 128. It is a two-way slab because it is smaller than 2.0, which is 1.41. For NED, the design action is 12.05. Next, for analysis. This analysis, it is a simply supported slab. For moment, short span, which is MSX, is 12.22, and for long span, MSY, 6.29. For main reinforcement, effective depth, dx equals to 93, dy equals to 83, and for short span, MSX, AS equal to 317.96. We use H10175, which is 449 mm square per s, and for long span MSY, AS is 183.38. We use H8175, which is 287 mm square per m. And for minimum and maximum reinforcement area, AS min is 93 mm square per m, AS max is 5120 mm square per m. For shear, minimum design shear force VED equals to 19.28. Design shear resistance VRDC equals to 2.47, which is smaller than 2.0. PI equals to 0.0056, which is smaller than 0.02. As a conclusion, VRDC equals to 53.3 kN, Vmin equals to 46.1 kN. So VRDC 53.3 kN is bigger than VED 19.28 kN, which is okay. As for deflection, percentage of requirement tension reinforcement, LD allowable is 38.34 and actual is 34.41. Actual is smaller than allowable, so it is okay. And for cracking, S max slabs for main bar is 384 and max bar spacing is 287, which is smaller than S max slabs, which is okay. And as you guys can see here, this is the detailing of ground floor slab for bedroom 1. And finally is ground floor slab, which is kitchen. As you guys can see here, on the left side is the original plan, and on the right side is the plan that we drew before we start with calculation. Next, for action, the thickness of slab is 140. This slab is two-way slab because it is smaller than 2.0, which is 1.28. And for design action, NED equals to 12.45. For analysis, this is a simply supported slab. Moment for short span, MSX, is 14.28. Long span, MSY, is 8.44. For main reinforcement, effective depth, dx equals to 105, dy equals to 95. For short span, MSX, AS equals to 328.64. We use H10 175, which is 449 mm square per m. For long span, MSY, for AS, we use is 214.98. We use H8 200, which is 251 mm square per m. For minimum and maximum reinforcement area, AS min we use 105 mm square per m. AS max is 5600 mm square per m. Next is shear. For maximum design shear force, VED equals to 21.85. Design shear resistance, VRDC, is bigger than 2, which is 2.38. For pi is 0.0043, which is smaller than 0.02. Overall, VRDC is 55.6 kN, Vmin is 52. So VRDC equals to 55.6, bigger than VED, which is 21.85, so it is okay. And for deflection, the percentage of requirement tension reinforcement, LD actual is 42.06, and for actual span effective depth, which is actual, is 33.39. It is smaller than allowable, so it is okay. And next, for cracking, the main bar for S max slabs is 400, and max bar spacing is 251, which is smaller than S max slabs, so it is okay. And last but not least, this is the detailing of ground floor slab for kitchen. That's all from me. Thank you.
I'm going to share with you the column. The specification is brace non-slender column, and as for the FCK, it is 25 Newton. The FYK is 500 Newton. The size B multiplied by H is 300 by 350 millimeter, and the effective length is 4.6 meter, and the assumed length and bar is 6 meter and 25 meter, and then the nominal cover is 35 millimeter. Now, the design moment for non-slender column, the design moment is MED equal to max, MO2 or M min, where MO is M plus NED multiplied by EI, where we get for the M, which is we need to find the maximum, which M bottom or M top, and then we get 40 kilonewton. And as for the EI, it is LO divided into 400, where we get 4,600 divided into 400 is equal to 11.5 millimeter. Next, for the MO2, it is 40 plus 1,800 multiplied by 0.0115, where we get the answer is 60.7 kilonewton. And as for the M min, it is NED multiplied by EO. EO is equal to H over 30, which is larger than 20, 350 over 30, where it makes 11.67 millimeter, where it is smaller than 20 meters. So M min is 1,800 multiplied by 0.020, and it is equal to 36 kilonewton. So the MED is 60.7 kilonewton, where we got this from the MO2. Next is D2, which is C plus bar length plus bar equal to, where it is 35 plus 6 plus 25 over 2, where it is equal to 53.5 millimeter. And then the D2 is divided into H, where we get 53.5 equal to 350, and it is equal to 0.1. Next, AS FYK divided into BHFCK, which is equal to 0.35, and then AS is equal to 0.35 BHFCK divided into FYK, where we got the AS is 1,837.5 millimeter, and the AS min is 413.79 millimeter squared, or 0.02 AC, which is equal to 210 millimeter squared. So the AS max is 0.04 AC, which is equal to 0.04 300 multiplied by 350, where it is equal to 4,200 millimeter.